everybody. Today I will discuss the differences between emerging and submerging coastline features. Areas that have been submerged or are experiencing higher sea level are referred to as submerging. Areas that have been uplifted from the sea and exposed are referred to as emerging. Submerging features are common on the east coast of the United States. As you can see here, this is a picture of Ocean City, while emerging coast or emerging features are seen on the west coast. This picture is of the west coast of San Francisco. That is not to say that you will not find submerging features in the west, but that they're most common here in the east coast. The west coast of the United States is an active coast, and it's being uplifted as the Pacific plate subducts underneath the American plate. The continental crust on the American plate is being pushed up as the oceanic plate is plunging underneath it. When this occurs, the continental shelf is now exposed and gets hit by wave action. Essentially, what happens here is this plate is being pushed up and it no longer is under the water. So this water here will continuously hit this continental crust and break it down through what we call hydraulic action and abrasion. Abrasion is just when little pieces of rock or broken down pieces of rock from the cliff hit other rocks and break it down further. This wave action essentially will flatten out the beach over time. So emergent coasts, like this one, are young and have yet to be eroded. So they're also known as erosional coasts because they're being eroded. As the waves continue to break down or erode this hill that used to be underwater, the first thing you get is a wave-cut cliff and wave-cut platform as a result of wave erosion. So these are called wave-cut cliff and wave-cut platform. So there's a cliff and here's a platform caused by wave erosion. Here are some photos of erosional coastline features. First, we talked about the hill being uplifted by tectonic activity, turning into a wave-cut cliff and wave-cut platform. Eventually, water will continually erode and break down this cliff, creating a wave-cut area that is essentially a hole in the wall on the wave-cut cliff that we refer to as a sea cave. You can kind of see one in there in this picture. A sea cave is a type of feature that you wouldn't want to be in during high tide because it would be submerged, yet you can walk around during low tide. Eventually, a blowhole can form, which is due to pressure differences between this area down here and the surface, which essentially breaks down this sea cave and separates it from the rest of the headland. You can sometimes see water coming out of these blowholes. And what you will get is what we call a sea arch, which is just an arch found in the sea. You can see one here in this picture to the right. Eventually, the top of this sea arch, or the keystone of it, will collapse due to weight and wind erosion, and it will turn into sea stacks, which are just rocks in the water. You can see one here This one's known as Chimney Rock on the coast of California. It is a sea stack. Sometimes they look even smaller, like some of these you can see in these pictures, and they could be called sea stumps if they're small enough. If they're big enough, they can be called sea islands. The prison of Alcatraz near San Francisco is on a secluded sea island or large sea stack, essentially. So I hope that you can see visually here some of these photos from California and the one on the right from Peru will help you to visualize the progression from first a cliff cut by the waves, wave cut cliff and platform, eventually turning into a sea cave, which then turns into a sea arch, and then sea stacks. Here in this picture to the right, you can see a cliff that became an arch. You can kind of see there's a cave in there. And some of these little guys are sea stacks, all in one picture. If you were to look at what I was describing in the last slide from an aerial view, you would see a headland which sticks out from the beach. It's an uneven beach. This is the cliff part that sticks out. The energy of the waves as it approaches this headland is concentrated right here. So that means that this is the area that gets the hardest hit by the wave action or abrasion. As all this stuff breaks down from here, what you get is wave refraction, which is the bending of the waves. So the waves start to slow down as they hit the headland, and they bend outwards because part of the wave is still going at top speed while the part that hit the headland slowed down. So at either side of the headland you have wave refraction or wave bending. When this occurs, the breaking down here causes all this broken down rock and sand to end up here and here in what we call the base. As this wave refracts, it creates what we call a longshore current, which is a current that travels parallel to the beach and deposits material elsewhere. This is very common in the west coast of the United States or emerging coasts, where you have erosion occurring in the headland and deposition occurring on the base. We live in a depositional or submerging coast, where we don't really get erosion anymore, we just get deposition. It is an old coast, it has already been broken down. Our closest tectonic boundary is in the middle of the Atlantic Ocean, so we have no tectonic uplifting. Our beaches are flat and mostly made up of sand getting moved around. So in order for you to think about how this compares to our coast, I want you to think of Ocean City on Fenwick Island. It is flat. The highest elevation is about 10 to 15 feet. While these areas tend to be steeper, and you can see an elevation change of a couple hundred feet as opposed to our only 10 to 15 foot elevation heights here. This is Fenwick Island and Assateague Island. These are barrier islands, and they're parallel to the beach or the mainland. They're meant to protect the mainland from storm surges and wave erosion. It's nothing more than a large sandbar, not stable continental crust. We have barrier islands all the way from the Carolinas to New York. As sea level rises, the islands move toward the mainland, making the bay side shallow and shallower. Look at this map. Assateague and Fenwick used to be one island until 1933. Hurricanes split them into two. We built these seawalls, you can see here, to keep them separated. And we developed Ocean City for tourism. you can see that Acetate Island has moved westward towards the mainland as sea level rises. While Ocean City over here is staying in place. Also, note the pile of sand over here on the east side of the island, on the north side of the seawall. This is the direction that longshore current is traveling. The longshore current is traveling south, and the sand is piled up in that side of the wall. The sand should be moving south to replenish acetate with the current and westward towards the mainland as sea level rises. Sea level is the highest it's been in 2 million years. The reason that Ocean City is staying in place is that we dredge sand from where it moves to where we want it to go. Lots of taxpayer money goes towards this maintenance. Look at this picture of Ocean City. Notice the dredge here. You might have seen these in the beach yourself. That is what we do, is we move sand from where it goes to where we want it to keep the property in place, and we don't lose money by losing the property to the ocean. If you have property here and you want to stop the sand from moving, you build a wall of stone perpendicular to the island. Like this, perpendicular to the island. These are called groins. But as the longshore current travels, taking sand with it, the sand piles up on one side of the wall where the sand is being stopped from going further. So this person owns a home here, and he's protecting his home. He's very happy. But then, in the other side of the wall, there's erosion, so that the sand is being taken away by the longshore current traveling in that direction. So what does the homeowner that lives over here do? He's angry. And he's losing his home to the ocean. He builds another groin to stop sand from flowing that direction. And so on, and so on, and so on. Ultimately, what ends up happening is you end up with multiple groins, and it's ineffective as a long-term solution. Longshore currents deposit sand from the mainland to other places too. So if this is the mainland, and you have a sea island over here, longshore currents traveling in this direction could slow down if they hit something shallow and dump their sand or deposit their sand here. What happens when a bunch of sand piles up and connect a sea island to the mainland? You get a tombolo, making this a tide island because now it is connected to the mainland. If sand keeps on moving with the longshore current and creates kind of a finger-like, or I think of it like a hook extension to the mainland, we call it a spit. Sandy Hook is a spit in New Jersey. Think of it kind of like it's just dumping out its sediment and spitting, or something like that. If the spit becomes big enough to close off, this is still the mainland over here, this bay area or a lagoon from the ocean, kind of blocking it off entirely, we refer to that as a bay mouth bar. I hope that this helps you to differentiate between emerging or erosional coast and submerging or depositional coast. Until next time.